Okay, welcome everyone to our webinar today on artificial turf, research on plastic pollution, PFAS, and health concerns. My name is Sarah. I'm the communications coordinator with Alaska Community Action on Toxics. And CHE Alaska is a program of ACAT and Collaborative for Health and Environment. And it's also part of CHE's broader international coalition of over 5,000 individuals across the globe. During today's webinar, our chat function is disabled, but please feel free to send in your questions using the Q&A box. So you're able to send in your questions at any point during the presentations. And at the very end, we'll try to get to as many as we can within the hour that we have. So I'll go ahead now and introduce our speakers. We're so glad to have you all joining us today. First, we have Dr. William de Haan, a researcher from the University of Barcelona, whose research focuses on plastic pollution in marine environments. And he will be discussing his recent study, which measured the presence of artificial turf waters. We have Susan Chapnick, who is the president and principal scientist of New Environmental Horizons, Inc., an environmental chemistry consulting firm. And we have Dr. Rachel Massey. She's a senior scientist and policy advisor at CHE and a senior research associate at the Lowell Center for Sustainable Production. So thank you all for being here. And now I will turn it over to Dr. de Haan to start us off. You're still on mute, Dr. de Haan. Yeah.
Can you hear me now? Perfect. Okay. Yeah, thank you for this introduction. I'm really happy to be here today with you all, sharing this work that we did. Yeah, my name is Liam. I've been working on plastic pollution for quite a time now. I'm basically centered on floating plastics in the Mediterranean Sea, so ocean plastics, but also I've been doing some research on rivers as well. So basically, this would be a sample of a typical sample that we will find of plastics found on the ocean surface or rivers. So what we do usually is we pick the plastics out of our samples and we scan them, right? So each of one of these scans have all different types of plastics. We measure them, we get the color out of them, we sort of characterize them completely. Right, so usually what we find floating on the ocean surface are fragments made of polypropylene, but also we can see a lot of foams made of expanded polystyrene, microbeads which are derived from facial scrubbers, for instance, and also filaments from fishing activities, films like hard sheets, soft sheets, and industrial pellets, which are used as the main component to produce or to mold in other types of plastic. So we've been sampling for over 10 years, and all these samples that we've gathered together, we've come across a lot of these green fibers that you see here on the right. And at first we thought they were really like something fishing related, but this is like an emergent pollutant. So we discovered that these were actually a lot of artificial turf fibers. So in 2023, we specifically investigated artificial turf fibers in the aquatic environment, right? We did this in collaboration with the University of Barcelona and the University of Cadiz, and we wanted to answer these three central questions. So first of all, artificial turfs are the important source of plastics in the aquatic environment. What is are these sources different or higher or lower than other types of sources of plastics in aquatic environments? What are the concentrations? Are they higher or lower than other types of plastics found there? And what are the properties? And also the properties is important to know, because then we can sort of give information to future studies so they can reliably identify plastics or artificial turfs in their studies. And finally, we wanted to know what the relationship was of these fibers with rainfall. So before I'm going to go dive into the study a bit, I'm just going to go through so what artificial turfs are. Basically, they are a composite material of different types of plastic and non-plastic products. We can see obviously the grass fibers, which are tufted into a few backing layers. We have a shock layer. We have other components such as drain pipes and so on. And also in some surfaces, we also have these granulated infill, especially in sport surfaces. And all these are of different chemical composition and different nature, right? So my point is here that environmental leaching will likely occur not only from the infill and the fibers, but also from all of these different types of plastics associated to the artificial turf. And the second point I want to make is one, these artificial turf components get into the marine environment or into the aquatic systems. Their environmental fate and impacts will largely depend on the chemical composition of each and one of these products, right? So this is important to know. So artificial turfs, so they can leach into the environment in multiple ways. So this is, as you can see here on the top left, we see a shoe. They can attach to shoes to close really easily. This is only 1 hour after being played on a sports pitch. They also floodings can have an influence in releasing and leaching artificial turf fibers to rivers and the ocean. But there are only a few studies that have evaluated or sort of evaluated how much of these turfs are lost from sports field. From these studies, it has been estimated between 0.5 and 10% of the fibers are lost annually. Of this percentage, between 0.1 and 6% are released to surface water, so to the ocean or to rivers. And this can be a lot actually if you consider that up to a full size football pitch can have up to 3 billion fibers, right? And I'm only talking about fibers, so artificial turfs associated to sports, but actually we can find a lot of different types of artificial turf surfaces. And nowadays we can find them everywhere, from decoration, in public venues, we can find them in private lawns, roundabout, and so on, right? So sports pitches are not the only source. So in this study, we basically focus on two areas, on coastal areas in Spain and in the river, specifically in the Guadalquivir River, as you can see here on the left. This is one of the largest rivers in Spain. And as you can see here, what we do is we use a manta trawl net, and we tow this net for a certain distance over the water to collect all the different types of plastics. We sampled plastic between 2014 and 2022. And then we also use the citizen science approach where we sample plastics really, really near a shore, right? This is sometimes really difficult to sample near shore areas. So we also did this using this Surfing for Science projects, which if you want, I can tell you give you some more information at the end of the presentation. And finally, to sample these, the Guadalquivir River, we use eel fishing boats. So the first results are, you can see them here. So the first thing we want to know is what were the proportion relative to the total plastic loads, right? We found that artificial turf fibers were found in over 50% of the samples. So 50% had at least one artificial turf fiber out of 417 samples. And if you look at the graphs here on your left, on the y-axis, we have the number of samples, and the x-axis, the percentage, right? And then the gray and the yellow are for river waters and sea surface waters. So what we see is that artificial turf fiber represented 1.2% of all the plastics in the sea surface and 0.3% in river waters out of 88,000 plastic items collected. But if we actually look to the larger fractions, so fractions that are larger than 5 millimeters in length, we see that artificial turf fibers are at much higher proportions, right? So we find that 12% of the plastics are artificial turf fibers in at sea surface, especially in nearshore areas where we find up to 16%. and only 2.4% in river waters. So the reason for why we find higher proportions among the larger plastics is basically because artificial turf fibers, they can be reliably identified under 1 millimeter length. So if they become smaller than 1 millimeter, we can't reliably say, oh, this is an artificial turf fiber. It might be a fragment, it might be a film, and so on. So this means that our data, so that observation is biased, right? So there is an underestimation of the actual artificial turf fibers we can reliably identify in the environment. So 16% of the plastics being artificial turf fibers is actually a lot, considering also that plastics degrade into smaller pieces, into microplastics, and then become more bioavailable to aquatic organisms. So we also look at the fiber composition, the color, the concentrations. We found that most of them are polyethylene and polypropylene. These are basically the most the most produced type of fibers now in the market. And as you might expect, most of them were green, followed by yellow, brown, and gray. Yellow and brown colors maybe due to chemical degradation over time in the waters. And interestingly, we saw that the concentrations were 50 times higher in sea surface waters than in river waters, right? So we find that 0.82 items per square cubic meter concentration in sea surface waters, and 0.01 items per cubic meter in river waters, right? So this difference we suggest that this could be like due to lower retention in rivers. So rivers might act more as conduits of fibers into the ocean, and the way around, we find that the ocean is not only for fibers, for all types of plastics. They are long-term accumulation zones of plastics, where plastics degrade over time. We also looked at sizes of these fibers in the environment. We saw that in river waters we have considerably larger and longer fibers than in sea surface waters, and this might be also related to what I said before: is that in rivers we have lower residence times than in sea surface waters, which means that sea surface over the time fibers would degrade into smaller pieces. Right, this might be one of the reasons why we find these differences in size. And if we look at the concentrations over time, we also see that fiber concentrations vary over time, and we saw that really we didn't find a relationship with rainfall directly, so at an event scale, but we did find that during the rainy season, as you can see here in the blue areas, the blue marked areas, we find higher concentrations usually of these fibers, right? And this is for both rivers and the ocean. And we calculated that in 1 year, up to 1.1 million artificial turf fibers might be flowing down only this river, right? So we can't really extrapolate this to other rivers. We need more studies for that. But for this river, we find that this is really a really high number, which is equal to 5.1 kilograms a year. Right. So I've talked a bit, but I've done a bit of an overview of what we found in rivers and what we found in coastal and nearshore areas. Right. We found that like I would say this again, but we found that most of the artificial fibers are concentrated in nearshore areas, right? Especially due to proximity of sources, probably. So we have an idea what's sort of in rivers and in coastal areas, but we really don't know how much of this is in other coastal areas, as mangroves, or how much is on beaches, how much is floating on offshore areas or in the water column or in sediments, how much is actually ingested by organisms, and what impacts do the artificial turf fibers have on these organisms, and how much is in the atmosphere, such as in urban dust or in terrestrial environments, right? So much research has to be done still on artificial turf fibers, but we know one thing for sure is that there are a lot of them, at least in the coastal areas, right? So artificial turf fibers don't only also impact urban biodiversity. Here you see a bird's nest made out of fibers. They also increase urban runoff. They contribute to the heat island formation in cities. and they also contribute to chemical leaching with about PFAS. We'll be talking about this in the next sessions, right? So, with this study, we've found that aquatic systems are really also full of these artificial turf fibers, and our next steps would be monitoring these systems in the future, right? If you want some more information, yeah, feel free to ask questions after the sessions. And here you have some websites, some links, some interactive apps on the data we've collected. So thank you very much.
Thank you, Dr. Haan, for walking us through your study. And as you mentioned, it's surprising that it's taken so long for turf fibers to be recognized as a significant source of plastic pollution in our waters. So your study is really important for highlighting and quantifying that. Thank you. And now we'll hand it over to you, Susan, to present more on the environmental impacts of artificial turf and how communities are working to address these threats. So thank you for joining us.
Am I unmuted? Can you hear me? Okay, great. Let me just get presentation mode. And you can see my screen okay? Okay, great. Thank you. All right, thank you, Dr. Haan. I'm going to present the environmental impacts of artificial turf fields. And as you may know, many towns and cities across the US, especially in my home state of Massachusetts, are grappling with this issue of evaluating artificial turf field projects in and around wetland areas and squarely in urban environments. Hopefully, we're giving you some information today of the science of the potential impacts and current information on the environment, so we can help municipalities make more informed decisions. I won't go through this again because Dr. Haan already went through what artificial turf is made of, so that was great. I can skip that slide. I'm going to go into environmental chemical concerns. And excuse me if I'm looking over to the right, I actually have two screens running here, so I'm going to make sure that I don't forget information that I want to impart. So chemical hazards escape from artificial turf fields. A number of these chemical components are soluble in water. Therefore, when it rains on an artificial turf field or it snows, these chemicals come off in the runoff from the field. In addition, chemicals that are not very soluble in water often stick to particles, and they'll stick to the infill particles, or they'll stick to the weathered plastic blades or the other plastic components, as Dr. Haan talked about, that are coming off these fields and getting shedded off these fields into the environment. I'm going to focus on several of them that are clearly hazardous to the environment, especially aquatic environments, and toxic metals. I'll talk a bit about per and polyfluorinated substances, PFAS, plastic chemicals, and 6-PPD quinone, which is a fairly newly discovered compound that is acutely toxic to organisms. The EPA has discovered 350 chemicals, identified, 350 chemicals in tire crumb rubber. Tire crumb rubber is the most common infill in artificial turf fields, historically as well as currently. And many of these are confirmed carcinogens and neurotoxicants. This is an example of a real field in my town of Arlington, Massachusetts. This is an older field, about 10 years old. The high school wanted to play on the field in the winter when there was snow cover, so they snowplowed the field. If you look at the upper left-hand corner, you see some clean white snow. That's the snow that they plowed off the surrounding grass area. Then the darker green is the turf, is the artificial turf. And in the foreground, the black snow, that's all tire crumb rubber coming off the field. One of the chemical groups of concern in artificial turf are PFAS. per and polyfluorinated alkyl substances. This is a class of almost 15,000 different chemicals. These are often called forever chemicals in newspaper articles because they persist in the environment. They're used in the manufacturing of the turf carpet grass blades and the backing. They've also been found in other components. And New England communities have found PFAS in artificial turf. There's a bit of a complexity in understanding the data for PFAS in artificial turf and coming off of surface waters and into the surrounding groundwater or rivers and contaminating soils as well, because there are different testing mechanisms for PFAS. Since there are so many different compounds that compose this huge class, some of the EPA tests only look for specific target compounds, and that's what those acronyms are there. PFAS, PFOS, PFOA, PFOA, etc. However, there are other tests that look at compound classes, for example, total fluorine and total organic fluorine, which sometimes can give a better indication of actual PFAS content in a material. Dr. Massey will be speaking a little further about the testing and interpretation and complexity of that. I would like to spend a minute on some current information that I've become aware of in helping a community in Rhode Island evaluating impacts of the artificial turf field. The Rhode Island Department of Environmental Management, RIDEM, and its Department of the Department of Health, DOH, sent a letter recently to the town of Burryville in Rhode Island, saying they're most concerned about the potential for PFAS from the turf to contaminate groundwater in the area. And they summarized some of the data that they have to support this concern. The data is from 2 wells, an upgradient of an artificial turf field installed in 2007, which had non-detect for PFAS 6. What that means is in Rhode Island, they only regulate 6 of these PFAS compounds, and then they sum them. So that well upgradient was not detected. There was no PFAS that could be detected by the instruments. The downgradient well was showing low levels of PFAS, and then in more recent years was showing levels around 20 to 30 nanograms per liter of these PFAS 6 summed together. However, in June of this year, this well showed 61 nanograms per liter of PFAS, and they didn't observe any obvious other source of PFAS, though I don't think that was investigated. The Rhode Island groundwater quality standard is 20 nanograms per liter. So this PFAS in the downgradient well is 3 times the amount of the Rhode Island quality standard. I know that Dr. Haan showed you some pictures. We know that these fields shed the fibers. I also wanted to show you that they shed the infill. This is tire crumb rubber infill that's shedding off a field. The left-hand picture shows the field on the left. The middle is the perimeter drain. These fields are constructed with a perimeter drain around the fields. Obviously, you can see that the infill particles get past this drain to the right-hand side. All that black are particles on the natural grass. However, this field was not maintained. It's a 10-year-old field, and you can see the magnitude of the accumulation of the tire crumb rubber in that drain. Besides PFAS, which I've just discussed, and particles, there are several other chemicals that are directly toxic to aquatic environments. One is zinc, and the Connecticut DEEP in 2010 did a study of stormwater directly off of an artificial turf field. They found whole effluent toxicity. What that means is that the entirety of the surface water that came off, they just took the surface water and they did lab experiments on aquatic toxicity according to EPA methods, and they found that the organisms died. They also found an exceedance of the EPA acute aquatic toxicity criteria. This is criteria under the Clean Water Act for zinc. In addition, a newly discovered compound called 6-PPD quinone is directly toxic, not just to freshwater fish, but to coho salmon. I'm going to spend a few slides on this because this is particularly important in the northwestern US and Alaska, obviously, with our salmon runs. 6-PPD is a compound, I'm not going to say the name of that compound, it's so long there, that's intentionally added to tires to prevent them from changing and becoming brittle during exposure to light, to UV light. It protects them from oxidizing. In that protection, the 6-PPD itself on the surface of the tire oxidizes to this compound called 6-PPD quinone. It turns out that this oxidized compound is actually more toxic to aquatic organisms than the intentionally added compound that was there already. This compound is present in tire wear particles from runoff off of roadways, as well as in tire crumb rubber infill. Chemical concerns of 6-PPD quinone were first discovered by Dr. Tien in 2021, and he linked directly to the fish kills of coho salmon that have been observed in the Pacific Northwest. The LC50, that means how 50% mortality of the organisms that are tested, differs by species, but coho salmon is the most sensitive species tested to date. And you could see below that coho salmon, especially for hatchlings, 50% of them will die in a solution with 6-PPD quinone of 0.04 micrograms per liter, which is 40 nanograms per liter or 40 parts per trillion, which is what we saw before. Since this information came out and additional information has come out after Dr. Tien's peer-reviewed paper, the EPA has recently published in the Federal Register in June of this year, acute freshwater aquatic life screening values for 6-PPD quinone that are extremely low. So for 6-PPD quinone, you see that in red on the screen, 11 nanograms per liter is the screening level. What that means is that 11 drops of 6-PPD quinone in 20 Olympic-size swimming pools will cause adverse effects on freshwater aquatic environments. That is an unbelievably tiny number, and it shows how toxic it is to the environment. In addition, if you look at the bullet on the bottom, there have been more recent research, and there are others, that artificial turf pitch with tire crumb rubber, and they call it pitch in Europe, and we call it artificial turf field here in the US, 6-PPD quinone is coming off of these fields. So that's a real concern. Besides chemicals, there is the concern of heat. This is a severe concern on artificial turf fields. Dr. Haan mentioned it. The field that you see here, there's a grass field on the left, which is blue, meaning that it's basically the air temperature, which I'm sorry I didn't put there, but it was close to 90 degrees. And the field on the right is the artificial turf field, as almost 155 degrees Fahrenheit. There's a lot of data on heat of these fields. They get upwards to 200 degrees at the surface. The Alaska Stormwater Guide says that warm water runoff from impervious surfaces are harmful to salmon and other cold water species. Therefore, these fields have the potential for warm water runoff, severely impacting the aquatic environment. There are many regulations and policies that can bring to bear to evaluate artificial turf fields. Under the federal policies, and I talked about several under the Clean Water Act, are the acute freshwater aquatic life values for a number of chemicals that can come off of these fields. State and local regulations and policies also exist for wetlands protection, stormwater management, climate resilience, plastic and microplastic controls, sustainability, and recycling. In addition, local watershed associations have come out opposing installation of artificial turf as hazardous to the watershed that they're protecting. In addition, the Alaska Stormwater Guide has stormwater pollution prevention guidance on toxic contaminants such as heavy metals and other chemicals that can come off these fields. Besides the direct impact to the environment from these fields, there are impacts on climate change resilience. According to the Synthetic Turf Council, 180,000 square foot field or pitch uses 200 tons. That's 400,000 pounds of infill and 20 tons of turf carpet. Current evidence shows that artificial turf cannot be meaningfully recycled. The incineration and quote-unquote chemical recycling that has been touted by the industry actually just pollutes the environment and does not produce any significant new plastic products. And there was a webinar on this. I'm sure we can put the link up for you later. In addition, artificial turf contributes to the climate crisis throughout its life cycle, requiring fossil fuels during production and emitting greenhouse gases during use and disposal. It's not consistent with sustainability principles because it has a limited useful lifespan of approximately 8 to 10 years, at which time it needs to be replaced. And the picture that you see on the right there is the turf carpet that was replaced from a field in Massachusetts. And that turf carpet was placed next to the field within a wetland. And those fibers and chemicals were getting into the wetland jurisdictional areas. Artificial turf fields alter wetlands. My focus is wetlands and climate change resilience. Wetlands regulations protect the value of the wetlands, to protect wildlife, to protect habitat, to protect aquatic organisms, to protect the ecological functions of the wetland. Are artificial turf fields consistent with these protections? We talked about pollution, chemical and particulate, getting into groundwater, surface water. It also gets into soil and sediment. In addition, an 80,000 square foot athletic field significantly impacts habitat for insects, other invertebrates, for foraging birds and small mammals, and affects wildlife connectivity and disrupts habitat, as well as heat effects, which we've talked about, and negative biodiversity impacts. In my town of Arlington, due to the adverse impacts on the wetland resource areas, as well as negative climate change impacts, I proposed to the town that artificial turf fields should be prohibited in my town. Based on that proposal, the town decided to set up an artificial turf study committee. This was set up in 2023, and the final report came out in 2024. The results of that report are on this website. The conclusion was that artificial turf fields can be considered an option, but only after careful evaluation of the practicality and feasibility of natural turf options. In addition, the town did come out and say that crumb rubber infill, tire crumb rubber infill, should not be used due to the hazards to health and the environment. So in conclusion, I would hope that municipalities and communities and regulators would take the following into consideration before permitting or installing an artificial turf athletic field. Consider chemical and particulate and plastic pollution that comes off these fields. Consider heat and urban heat island effects, as well as heated water into cold water fisheries and effects on aquatic organisms. Life cycle costs. If we consider that an athletic field would last 20 years, which is a very reasonable amount of time, then artificial turf fields cost twice as much, 2 times as much as a natural grass field, because it needs to be replaced twice. And the installation, replacement cost, and disposal cost of that plastic field makes it cost 2 times as much as the natural turf field, even though the natural turf field requires more maintenance annually. Consider location, whether these fields are near critical resources or wetland resources, habitat loss, climate impacts, and sustainability. And I hope that participants might consider a practical alternative, organic or sustainably managed national grass sports fields. There's a really good YouTube video from experts of organic and sustainably managed sports fields that just recently came out in May of this year. Thank you very much, and I look forward to answering your questions.
Thank you for that excellent presentation, Susan. I know there's lots to cover just on the chemicals of concern and environmental threats of this side of this topic. So thank you for walking us through it all. That was great. And now I'll pass it over to Dr. Rachel Massey to talk to us about the human health effects and more about PFAS testing.
Great. Thank you, Sarah. And I'm going to be just speaking briefly without slides, and I'm going to ask, excuse me, I'm going to ask Sarah to share some links as I go along. So I'm going to discuss 2 areas very briefly. I'm going to note some of the human health concerns related to artificial turf, and then I'm going to share some information about resources related to PFAS in artificial turf in particular. Starting with the health concerns, I thought I would just really briefly summarize information that has been covered very thoroughly in other webinars, in particular by Dr. Sarah Evans of the Icahn School of Medicine at Mount Sinai. So for more detail, you can see an earlier presentation on this topic by Dr. Evans on the CHE website. And Sarah, if you could put that link into the chat. As you've already heard, artificial turf materials can contain a wide variety of chemicals. Many of these chemicals have known or suspected human health effects, and many others have not been studied fully to determine their health effects. And it's also important to keep in mind that a lot of the toxicity information that we have tends to refer to individual chemicals, whereas the real-life exposures that we experience encompass complex chemical mixtures. If an artificial turf field is made using waste tire materials, as Susan was discussing, those materials can contain a number of chemicals that are known or suspected carcinogens. Just to give one example, they tend to contain polyaromatic hydrocarbons or PAHs, which can pose significant carcinogenicity concerns. And you've just been hearing from Susan about 6-PPD and 6-PPD quinone. There are concerns about human exposures to those chemicals as well. There was a study conducted in China that found both 6-PPD and 6-PPD quinone in urine samples from adults, children, and pregnant women. And we're really just at the early stages of understanding the health effects of some of these chemicals. So those are just a couple of examples. PFAS also pose a variety of human health hazards. I think I won't go into those here, but again, Sarah, I'll ask you to just share a link for those who might find that useful. And A key concept to bear in mind is that children are uniquely vulnerable to toxic chemicals. An exposure that might not have a significant impact on the health of an adult can have a significant set of long-term consequences if that exposure occurs during a window of susceptibility. Regarding heat, as you already know, in sunny, warm weather, artificial turf can become very hot. Surface temperatures have been measured up to 200 degrees Fahrenheit, and heat-related illness is a really serious concern for high school athletes, so it's really important for teachers and coaches and others to understand this hazard. And it's also important to be aware that children are not as able to regulate body temperature as adults are, so that's an additional area of particular vulnerability for children. Sarah Evans has also pointed out that the surface temperature on artificial turf is not just a concern for sports teams, it's also a concern for school bands, which can spend significant amounts of time on that really hot surface. Artificial turf also increases risk of serious skin abrasions, sometimes referred to as turf burn, and that in turn increases risk of serious infections. So just to wrap up this really quick summary on some of the health concerns, Mount Sinai has tips for safer play when you don't have a choice about being exposed to artificial turf. So just a few of those tips are avoid use on hot days. Very important to monitor surface temperature as part of your protocol for deciding when it's safe to have young people playing on that surface. Avoid passive recreation such as picnicking, wash hands after play, clean cuts immediately, brush hair and shower as soon as possible after being on the fields. And if you have to use an indoor artificial turf field, maximize ventilation of that indoor space. And again, thanks, Sarah, for sharing that link. So now I want to move on to the other topic I want to cover, which is PFAS testing. And here I'm summarizing work that I've done with my colleague Lindsay Pollard at the Lowell Center for Sustainable Production at UMass Lowell. At the Lowell Center, we're doing this work as part of our broader mission to help businesses and communities identify chemical hazards, reduce toxic chemical use, and assess and adopt safer alternatives. So in many cases, communities or the consultants working with them are ordering lab tests to find out whether PFAS chemicals are present in the artificial turf product that they're considering purchasing or have already purchased. And so we've recently created some resources to help explain these lab testing issues in more detail. And so Lindsay is sharing her screen now and just showing you a couple of examples of the materials that we have online in case you find that you need information at this level of detail. So we have a fact sheet on test methods and a fact sheet with examples of tests that have been conducted in both academic and municipal and other settings. And we also have a blog post about it. So so we just want to point out these resources and then mention a few of the points we cover in them in case you're facing any of these questions in your own community. And again, Sarah is sharing those links, and we'll also have these on the webinar webpage for those of you who are watching this later. So one of the issues that we cover in the fact sheets is that there are a variety of types of PFAS testing. One type of PFAS testing is targeted testing. So what this means is it's a way of looking for the presence of specific individual PFAS compounds. You can do targeted testing to look for just a couple of PFAS compounds, or quite often targeted testing may be done to look for 6 of them for regulatory purposes. There are tests that might look for 40, or you could look for 70. Regardless of the details, these are all ways of looking for a predefined list of chemicals. So this is really important when you're interpreting test results. If you're in a community where some of this testing has been done and you're looking through those reports, if a targeted test doesn't show the presence of the chemicals that test looked for, that doesn't necessarily mean that the product is free of PFAS. It only means that you didn't find the specific ones you checked for at the detection limit that was used in that test. So then what do you do if you want to look beyond that predefined set? Again, bearing in mind there are thousands of PFAS chemicals. One useful option is to do a total fluorine analysis. This measures fluorine atoms without identifying specific compounds. And then you can get more specific by doing an organic fluorine analysis. So that considers only the organic, i.e. carbon bonded form of fluorine. And again, just bearing in mind for context that PFAS are organic compounds and they contain carbon fluorine bonds. So looking at total fluorine and looking at organic fluorine is an element of the testing toolbox that can help you get a sense of the quantity of PFAS that might be present, because these approaches are not limited to a predefined list of individual chemicals. There are other tests that are also useful, such as a total oxidizable precursors assay. We can talk more about that if needed. And then another concept we cover in these resources is the importance of understanding detection limits. So for example, if you want information at the parts per trillion level, Susan gave that example of the one drop in a vast quantity of water, you need to make sure that the tests you're running will actually give you that information. If the tests will only give you information at the parts per billion or parts per million level, then you want to know that up front. So anyway, these are detailed points that become relevant for communities that are doing this testing. But I want to just wrap up with one core concept related to PFAS. As we've already discussed, PFAS are a large family of chemicals, including thousands of individual compounds. Unfortunately, PFAS are now widespread as contaminants in our environment and unfortunately in our bodies. Why is this the case? This has happened because these chemicals have been used in a wide variety of products and processes. So that's how they've become contaminants in our environment. As with other chemicals of high concern, we now have a dual task. We need to clean up existing contamination, which unfortunately is very complicated and costly. And we need to find ways to turn off the tap to prevent the introduction of any additional PFAS into our environment. So this is why you're seeing more and more attention to discussion of PFAS sources. And it's also the reason why many communities want to test products for PFAS and or get full and accurate product ingredient disclosure before they make a new purchase. Again, it's just about this broader effort to turn off the tap and stop putting more PFAS into our environment. So I will stop there. Thank you very much, and I look forward to the discussion.
Thank you. That was great, Rachel. And now I think we're ready to move into the Q&A session. We have a few questions already, and I also want to invite our speakers to jump in if you see a question that stands out to you that you'd like to address. But maybe we can start with this question from Karen about, is there any research on what can leach from the non-chrome rubber infills that are being used?
Yeah, I can comment on that. We have done research on the other infills, and we have a couple of resources related to that, and maybe Lindsay can put those into the chat. We have a report and an article that both talk about the range of other infills. So other infills that can be used include other rubber products, other plastic products, and plant or mineral-based options. And so some of these other products can contain some of the same chemicals that you can find in tire crumb, although they might not necessarily, there might not be as many of them or the same concentrations. But so for example, if you're using another rubber product, there can be other rubber chemicals, including vulcanization compounds. In other plastic products, there could be plasticizers. And then in general, with the plant-based materials, you're not going to find as many of those industrial chemicals, but it's still worth checking and testing in case those materials have been treated with any chemicals or carry any contaminants with them. Yeah, and then in terms of metals, some of those metals like zinc or chromium, for example, can also show up in some of the other infills. So as a general matter, waste tire materials pose the highest level of concern based on the number of chemicals and the toxicity of the chemicals and the concentration of the chemicals. But there are concerns with some of those other infill materials as well. Yeah, and I think those links are now in the chat, or I'm gonna actually, Lindsay, that just went to hosts and panelists, so you can just send it again to the full.
Yeah, I'll send that.
Yeah, okay, great. So thank you.
Liam or Dr. Haan, would you like to answer that one question about your study and the type of net that you used? Yeah.
Yeah. So the question is, what do you use a manta net? Right. So, and also like I'll just read the question there. What do you use a manta net? The only sample the surface waters, and lots of the microplastics are not at the surface. Also, fibers are mostly likely to pass through the net because of their shape. So that's completely true. We have focused mainly on surface waters because our research focused on these types of on this environment. But we expect that most of the fibers would be floating at the surface, since most of them are made of polyethylene and polypropylene. About 90% of the market makes fibers of these two chemical components. So these are usually less dense in seawater, river waters. They should be floating. If we talk about rubber crumb, most of them would be likely in the sediments, right, or in deeper layers. We have no information from other components from the turf. And just to say something else, so yeah, they would likely pass through the net, but we're using really small mesh sizes of 0.3 microns. Sorry, 333 microns. So yeah, there would be a small fraction that could go through the nets, but also this is a fraction that we can't reliably identify because they're so small. We can't. They might be green, but we don't know if they're turfs or not. They might be fragments.
Thank you. Maybe we can jump to the question about are there any studies on the impacts of crumb rubber used for playgrounds or other play surfaces or as mulch?
Yeah, I can comment on that one also. So yeah, there are concerns about materials used on playgrounds. In some cases, waste tire materials are used just as a rubber mulch for playground surfacing. And so that is a significant concern, because then you've got small children exposed directly to tire materials, falling on those materials, picking them up and playing with them, possibly even ingesting those materials. So, so that's a significant concern. And then pour-in-place materials also incorporate materials of concern. So that's the sort of smooth, often colorful, rubbery, bouncy surface that you often see at playgrounds. So that can also contain waste tire materials as well as other rubber materials and adhesives. And those pour-in-place materials also, even though they look very nice when they're first installed, they break down over time. And if you look in the surrounding area around a playground with pour-in-place surfacing, over time you'll see those particles start to be dispersed into the environment. In general, a safer alternative for playground, there are various safer alternatives, and they include using wood chips or engineered wood fiber, which is basically a specialized type of wood chip. So those are preferable alternatives for playground surfacing. And we have a report on playground surfacing. So I guess maybe Lindsay can send that link to Sarah, and Sarah can put it in the chat. And there's also a webinar that we can point you to that we did specifically on on playground surfacing, in case that's useful.
Thank you. I will share that. And if any of our panelists want to pick a question that they like to address, feel free.
I would just like to say that many of the questions have to do with chemicals and health effects on children. And I would point you to Dr. Sarah Evans, who is a participant and has posted in the Q&A a link to information from the Icahn School of Medicine at Mount Sinai in New York that might have some of the answers to your questions about that.
There's one question about phthalates and artificial turf, but they're not often a topic of discussion. Can we, this question's from Connie. Is there anything we can say more about phthalates? Yeah.
Well, I guess I can say, yeah, so phthalates are plasticizers that are endocrine disruptors and have a variety of adverse health effects. And phthalates have been measured both in waste tire materials used in infill and in some of the alternative infills. So they are one part of the mix when you're playing on these rubber or plastic materials.
Thank you. All right. It is at the hour, and looks like that's all the questions we have time for today. But thank you so much to our speakers for being here and for your work on this topic. And thank you all for sending in your questions. For those who are asking about it, a recording of this webinar will be available in the next couple of days on our website, and it'll also be sent to your emails along with all the links and resources. So thank you everyone for tuning in, and we will see you next month for our next webinar.
Thank you.
Thank you.